My name is Ron Fuller. I'm a senior technical product manager inside of the NSBU at VMware. I focus on networking specifically with regards to VMware Cloud on AWS. So we've got I think, a good agenda to kind of review some of the connectivity requirements and what customers can expect with this solution. And let's dig right in. So from a high level, we've got some topics we're going to cover with regards to networking inside the SDDC, the software-defined data center. How do we connect all the things inside of the data center together? And then where we'll spend the majority of our time is on the current connectivity models. How do you get from your on-premises infrastructure into the software-defined data center? And there's a number of options, and we'll go through them, talk about some pros and cons with regards to where we see customers being successful, and dig into some of the fun networking aspects there. Then we'll transition into security inside the data center, because security obviously is always an important consideration. And we'll go through some of the capabilities that we offer in that regard. And then we'll touch just briefly on operations inside the software-defined data center, and finally some resources to help you get further on your journey into the software-defined data center. So if we focus on networking inside the SDDC, we do have a number of different ways to connect into the data centers and to the service. All of it is powered by NSX-T, specifically the T version of NSX. And the idea was really to be able to provide that consistent capabilities and experience from the on-premises infrastructure for customers who have NSX-T on-prem into the software-defined data center. And for those customers who don't have NSX-T on-prem, no problem at all. We still can provide the same experience and connectivity that they would have had on-prem with NSX-T in the software-defined data center powered by NSX-T. So one of the things that's important to note, I know probably a few of you have been exposed to NSX from previous field days, and hopefully some of you are using it in your production environments right now as it is. It's not necessarily the exact same. It's the same binaries. The way it's accessed, though, is a little different. It's a simplified interface, and we'll see how it manifests itself as we go through the discussion. There is also API access, so for those of you who are automation wizards, you can still do all of your cool automation functionality, like the Terraform capabilities that we were just discussing a little bit ago, as well as the normal just REST API functionality. So that is an option as well, to be able to configure and automate and tie into the entire infrastructure. When we look at kind of why we picked NSX-T to do it, it just made sense, right? We've had 6+ years of experience with software-defined networking, and as customers transition into the cloud, the flexibility and capabilities that the SDN functionality brings to the table are important to have in that environment. And it just made sense that, hey, we've got this on premises, let's bring it into the cloud as well. And we will continue to add more feature functionality as it goes, because it is a service, right? So it gives us some pretty cool opportunities to insert functionality over time, and do it in a simplified manner, so the customers don't have to go through a bunch of hoops for lifecycle management. So it's definitely a different experience from a customer perspective than running your on-premises data center. So if we look at the functionality inside the data center, what we're actually doing, we're creating networks inside of the software-defined data center. All of this is done inside of the AWS constructs, the VPC inside of AWS, and it's all done on bare metal, as Narayan mentioned earlier, right? To instantiate this, we built a couple of routing capabilities into it, one of them being an edge router. For those of you who might be familiar with NSX-T on premises, that edge, the green hockey puck, if you will, that's there on the center of the screen, represents what we would call a T0 router. For us, we don't really refer to the tiers of routing inside of the product. We really have edge routers, we have the management gateway, and then the compute gateways. And those provide the separation of networking and firewalling between the different portions of the environment. So as the name implies, a management gateway is there to provide connectivity into vCenter, NSX, if you're using maybe HCX for data center migration and connectivity to your on-premises infrastructure. some of those HDX components would live inside that management infrastructure as well. And then the compute gateway part of it is where customers would build networks that their actual workloads would connect to. So your web and app and database VMs or your Kubernetes environments, whatever application you're using would connect into that blue area into the CGW. So it's provides that separation. It all goes back together into at the edge, and then that edge has a myriad of options that we'll go through, I promise, that talk about how we get back into our on-premises data center or even to another SDDC, right? Maybe I've got multiple SDDCs. One of the things I think is interesting about the approach that we've taken is we're trying to simplify the networking experience for customers. We want customers to be able to onboard and take advantage of the service quickly without necessarily having to become a networking wizard. And one of the things that we're able to do is not necessarily have a routing protocol between our edge and our CGWs. Because it's software-defined networking, we get to kind of make our own rules, right? And the rules that we're living by is it's a programmatic route configuration, right? Which also simplifies the infrastructure and also reduces the amount of overhead we have. We don't have to run OSPF and have to worry about area adjacencies and all of the other stringent requirements that OSPF brings to the table, or even BGP, right? We do run BGP, and we'll see that illustrated later, but in between the internal components of the software-defined data center, there isn't a dynamic routing protocol. It's programmatic because the controllers of the environment understand how the infrastructure is built, what it looks like, and how to instantiate that to the actual workloads themselves. And then, of course, we've got pervasive security. We'll talk about security in one of the sections closer to the end. But security, because it's part of NSX, it's not a bolt-on or an add-on functionality. It's integrated into the product, right? So we've got our micro, and customers can pick and choose, use both, use none. It's very much a choose your own adventure from that perspective. And we'll talk through some of that as well.
Ron, when you mentioned the edge router, is that the VM-based edge appliance or is that a bare metal edge appliance?
It is a VM-based appliance, absolutely.
And then when you talk about the compute gateway, is that something like renamed tier 1 router? So is it a programmatic construct, or is it a VM, or is it something else?
It's a T1, right? So
Thank you.
You're familiar with the architecture, right?
Yeah.
So you understand that it's not really a virtual machine in and of itself. It's an instance inside of the edge VM itself. So, yep, yeah. We and again, this is in an effort to try to make it easy for customers to consume and not have to dig into a ton of details to get up and running quickly. So when we talk about the simplified user interface, if you're used to the on-premises environment for NSX, this is a pretty significant departure. If you're not used to it, this actually is very simple to consume and to take advantage of quickly, which is one of the goals of VMware Cloud on AWS, right? It's to make customers successful quickly without having to jump through a bunch of headache and heartache. So you can see there's just a list of things you can configure on the left-hand side. And this is really the majority of the networking functionality that's there. So there's not a ton of detail that you have to worry about. You don't have to worry about transport zones or transport nodes. That's part of the SDDC build out that we do for you when you subscribe to the service and are onboarded. So again, the approach is, hey, I want to get up and running as quickly as possible. And you know what? Up and running doesn't, for me, I would enjoy this part of it. But for most of our customers, they just want workloads to go into the environment and communicate and run their applications, not spend a ton of time digging into networking details and corners and nooks and crannies.
Now, Ron, whenever someone says no need to be a networking guru, I become nervous because, we all know that you are abstracting details that will bite you eventually. But nonetheless, do you plan to offer something like this for the on-premises deployments? Because, it's a good idea to prepackage things with as many correct defaults as possible and not allow people to turn the nerd knobs.
I don't know of a plan to bring this to the on-premises environment, but I'll certainly pass the feedback on to the team. I'm sure they're interested in it too, because truly, this simplified experience is something that we've had a lot of customers give us really positive feedback on. So,
hey Ron, I had a quick question. in regards to some performance for the bare metal configuration. Are you guys using elastic network adapters on the AWS side, or is it all just traditional ENI networking configuration from Amazon?
Yeah, we're using elastic adapters inside of the i3 nodes that we're using.
All right, but are you using the high performance, the elastic network adapter, high performance ones from AWS that are, because those are all optimized for their AMI image types to get, I think they're up to 20 gig, right? That they're doing now.
Yeah. These are the optimized ones, right? So it's a 20. I think it's a 25 gig NIC.
Yeah.
That we're using. So yeah. And each instance, each server, each Nitro has multiple of them to provide different connectivity functions that we then in turn map kind of behind the scenes into VLANs for some of the backend connectivity, for the ESX host connectivity, and then virtualize it to present it upwards to the NSX stack as well.
Great, thanks.
You're welcome. So if we look at how a network is built inside of VMware Cloud on AWS, it's really, really simple. And you can see it's literally click add segment, give it a name, give it an IP address, choose, do I want to have DHCP enabled? If I do, what range of addresses do I want? And this is an internally managed DHCP server inside of NSX. Or I can take advantage of an IPAM solution that might reside on premises and configure a DHCP relay and have those DHCP requests forwarded and managed to centralized service. And that's it, right? There's not a lot of hoops and steps you have to go through. So again, simplification is kind of the goal here.
Just to be on the safe side, as you're using overlay virtual networking, AWS does not see these addresses, right?
So we're using Geneve, right, internally amongst the ESX hosts, and then if they need to leave, they either go through an IPsec VPN or whatever the other external connectivity is, and they would see these source IPs unless they were added.
But the AWS orchestration system does not see these IPs, so it's not managed by them or anything.
No, it is not.
Yeah.
Correct.
Thank you.
It's either managed by VMware or your IPAM solution of choice.
Quick question about DHCP. It does seem pretty basic, obviously. I was just wondering, are there any plans to expand that into a more capable DHCP service, or is it going to remain that way?
So it's definitely on the roadmap to improve the DHCP functionality, to be able to do more advanced assignment of DHCP options and things of that nature. But it's not there right now. Yeah, it's basic IP address and basic attributes.
Right.
And then do you have to do the sole selection between V4 and V6? So, on the NSXT side, I know it's a bit of a challenge, but what's going on in V6? Because you're a typical, VPC, you can assign a /56 on the V6 side and still use whatever you want for sizing on the V4 side. Is there anything that's happening there?
So V6 is on a roadmap. It's not there today.
So I had a question about security segmentation. So one of the uses that's often done is you create a segment with a particular IP range, and then into segment is where you traditionally would drop a firewall or something because you don't want to, so you'll separate app from DB as you've done with this segment example. How does that interact with any security parts? Is that coming later, or have I short-circuited your presentation a bit?
Yeah, so that'll be coming up. So we'll talk about microsegmentation and the capabilities that we have in that space in probably 10 slides.
Very cool.
Awesome. So let's talk about current connectivity models and what we support from a connectivity. One of our most popular options, and this is mostly because it's the fastest for customers, and again, speed of consumption and use of the service is one of the primary goals of VMC, is to use a VPN. Right, so we've got a couple of VPN options, one of them being a route-based VPN, where I'm configuring a BGP session between my on-premises environment, whether that's a firewall or a router, whatever it is, as long as it speaks BGP, and configuring that VPN termination on the NSX edge router and exchanging routes via BGP for that. For some of our customers who who either don't have equipment that runs BGP or don't. We also support what we call policy VPN. So I'm able to define a policy and say, hey, these networks are reachable across, and then it's distributed to both sides. So it's something some of our customers that use for very simple connections. Maybe I only have a single app that needs to live out there, and it's on a couple subnets, and I don't need dynamic routing and updates to happen. Policy-based VPN is an option. Because it is IPsec, again, any compliant IPsec compliant endpoint can be an endpoint. We've got a whole slew of encryption options and IKE methods and things. So we've got a very large compatibility from that standpoint. Where a lot of our customers are transitioning to, and almost all of them start with VPN day one because they either don't have Direct Connect DX in their environment today, but where they start to transition to is, especially as they consume more and are onboarded at a higher level, is to use a feature through Amazon called Direct Connect, which really you're putting an Amazon router, you're connecting one of your routers to an Amazon router, and then it's a pipe into the software-defined data center. And there's a couple different choices that you can choose from, whether it's a private VIF, which private virtual interface, which means that it is not a public IP address. So pretty well named, right? Public versus private. And that allows me to be able to establish a BGP connection from my on-premises environment to a router inside of the VPC itself, and then use route propagation to propagate those routes into the edge and have my advertisements work from that standpoint. And I've got a slew of options with regards to how my DX can be configured from a speeds perspective. I can get a 1 gig or a 10 gig. And then there are also partners out there who offer DX at lower bandwidth rates as well, or anything kind of in between. So again, it's kind of a choose your own adventure with regards to what your requirements are as to which speed of DX you might take advantage of. But you've got options.
Hey, Ron, just a quick clarification there. So when you're doing a direct connect, you said you share the routes to the edge. Does a direct connect actually terminate on your edge, or how does that actually function with AWS specifically? Is there any additional configuration, or can you walk through how that?
So the good questions, right? So the actual BGP connection is established between your on-premises environment and an AWS contract called a VGW. And then the VGW uses route propagation to send that into the edge. So the BGP session isn't terminated directly on the edge, but there is a high-speed connection from the edge into the VGW. So we've got that connectivity and plumbing done there. That also gives us an opportunity to change some of the routing for the backend NICs on the vCenter servers, or I'm sorry, the ESX host for things like vMotion, right? To not have to pass through the edge to get back to my on-premises environment for replication, things of that nature, right? So it's a good way to kind of streamline the connectivity and it still provide very high performance and also a path into the environment if the edge were to have a really bad day.
Now that you mentioned route propagation into edge, I have to go into that one. Are you actually getting it through BGP or something, or are you just polling the route table in API through API and pick the routes from the route table?
Through API. We're taking advantage of route propagation inside of VMC. So that's one of the enhancements we had to make to the NSX code, because obviously on premises, hey, I would just use BGP or I guess BGP or static routes, right, depending on your religion. But we had to make some configuration changes so that we read that API properly to do route propagation.
So you're using API as a better BGP.
That's absolutely one way to look at it. Yep.
Hey,
much lower overhead, right?
Ron, I had a quick question around you have public VIVs
yes.
in there. How much of the public AWS space is actually making it across? Is it API specific about what you're actually exposing from the ones that you're using, or many people on Direct Connect will also use this as a public access gateway to get to the rest of the AWS services. So if you're tying those in within your SDDC and you're making use of public AWS services, is that backhauling all the way across the direct connect? Does that have a local hop off through the edge? Where is that happening? How are you guys using, the equivalent of service endpoint configurations and things like that? How does that traffic actually look in this sort of configuration here?
Yeah, so if you're using public VIF, because it is a public IP address, this direct connect would now have a VPN across it to get into the software-defined data center. So, and then, but the benefit of using public VIF is that, hey, I now have the internal connectivity to all the other AWS services. So if I've got maybe a preponderance of AWS connectivity I need from my software-defined data center, public VIF might be more attractive than having things backhaul into my on-prem data center to go back out to AWS, right? So I can look at it as a traffic optimization vehicle.
And if you're using the public VIF, can the portion that sits within your data center also access outbound through that to be able to get across? So it can leverage a direct connect link to actually go out.
If you have like a default route to say, hey, everything else is out this way, then absolutely you can send it through the software-defined data center. Yep.
Finally, if I need to run a VPN over Direct Connect for compliance reasons, do you support that?
We do.
Okay, thank you.
Yep. So that kind of segues into a bit of the other option, right? So if I've got Direct Connect, maybe I want to use VPN as a backup, right? So I can use a route-based VPN, and we've tried to make this super easy. Literally, it's a radio button you click to say use VPN as backup, and that will adjust the weighting that we use for routing to be able to say, hey, the route-based VPN is just there for backup in the event that the Direct Connect has some sort of catastrophic failure. So again, just more options. So if we look at Transit Gateway, this is an AWS offering today, right? So Transit Gateway is a solution that Amazon created to help simplify connectivity between multiple VPCs and customer locations. Previously, they had a concept called a Transit VPC. Transit Gateway is here to simplify this. When we talk about Amazon provided TGW, the connectivity from the TGW into the edge is a VPN, right? It's not a native attachment, which can pose some performance considerations, right? Because now I'm looking at, hey, I could have had a really high speed connectivity into my TGW, but now I need to do VPN for the connectivity. With that, we support ECMP, so we can have 4 VPN tunnels established between the TGW and the edge to start to spread the load across, right? So depending on your addressing, source and destination, and the hashing that's created from it, it's not necessarily a linear bandwidth increment because it's a hash that's based on the two tuples. So something to keep in mind that it's not necessarily linear, but it is something we have customers taking advantage of to help increase that bandwidth from their edge into an AWS provided TGW.
So just to be clear, you did exactly the same thing what Cisco did with CSR 1000V in the middle, only you're using Transit Gateway for that. So everything you do is going through VPN circuits.
Yes. Yep. Anything in this topology diagram, if I'm on premises and I go through my direct connect into my gateways, or if I'm in a VPC connecting to a service in the SDDC, it's going through a VPN.
So what we've seen previously on the roadmap slide where it said, well, you can integrate the Transit Gateway now, it's effectively VPN all over the place.
I don't know how much detail I can give you. The quick answer is it won't be VPN based, right? So when we start talking about the VMware managed TGW, it will be a native attachment to the TGW.
Thank you.
Right. So, can I just quickly clarify one thing as well? Is it right to assume that route-based VPNs is a prerequisite to this as well, and policy-based?
Yeah, absolutely. Good clarification. The policy-based VPN doesn't support ECMP. I need to have a routing protocol to be able to do that hashing and spread the load across multiple links, and policy doesn't do that.
Yeah, thank you.
Awesome. So stay tuned for more information on VMware Managed TGW as we get closer to releasing that. There's a lot of really cool things with it that I'm excited to share with you at a future date. So let's shift focus and talk about security inside the data center. And let's talk about how we really have intrinsic security built in. We've got a couple different options for firewalling. We've got the management gateway, which we saw earlier, right? Is that router down at the bottom for our management constructs. And this is an example of default rules, right? These are literally screenshots from a new SDDC I just stood up the other day. And then we've got compute gateway for our actual workloads themselves. So just like an edge firewall inside of on-premises NSX, I've got the opportunity to configure whatever security policy is appropriate for my environment. But then I also have that distributed firewall and that microsegmentation functionality because it's inherent to NSX. So let's look at microsegmentation. And really, I'm not going to go into a ton of the concept because I think most people probably are familiar with the idea of microsegmentation, being able to provide almost a per VM type of firewall experience where I can have VMs on the same network talk amongst themselves or VMs on the same network not talk amongst themselves, instantiate that in the kernel of the hypervisor, do it very, very high performance, take advantage of stateful connectivity, and really secure my environment. This is something that customers have been doing for a number of years now with the on-premises NSX functionality. We've brought this into the software-defined data center so customers can take advantage of it there and then continue to increase their security posture, minimize their attack surface, and simplify their security policy. And that simplification of the security policy is really through the attribution of using non-traditional attributes instead of the IP addresses, right? Let's use tags, right? So I start to get what I almost refer to personally as IP address liberation, right? I don't care what the IP address of my virtual machine is, as long as it has the right tag that's specified in my policy, it's now being protected by that policy. Granted, it works both ways, right? I could also screw it up and expose it by applying the wrong tag, but it's much more flexible from a tagging standpoint than it is to use and take advantage of having to have a Rosetta Stone document of the IP addresses of every machine across my entire enterprise.
But Ron, you're still using IP addresses internally, right? So if you're not checking the source IP addresses that the VMs are sending, I can theoretically bypass all this and just spoof whoever I want.
No. So we're still doing the IP address. We do a mapping of the IP address based on the tag, right? So the actual firewall itself, when it's instantiated in the ESX host, is a traditional firewall, right? It's got all 5 tuples of information there. The differentiator being that the policy is defined using tags as opposed to the IPs, right? But we take care of the work so that you're not spoofing and not doing the bad actor type of things behind the scenes.
I have a question on tagging. Is it possible for me to synchronize or export tags between AWS and the SDDC platform so that I can share them and I'm not duplicating work?
When you say AWS, are you referring to like native VPC security tags?
Yeah. So just tags in general in the class. So I'm able to keep a consistent set of tags between what I'm tagging my VMs with and what I'm tagging my cloud assets with.
Yeah. Today the answer is no. Okay. So you get to be really good at automation and scripting to auto-populate it in both places. But that's definitely something that we hear as feedback for improvement from customers. So
okay, thank you.
Yep.
Yeah. So a question on being able to look at, for example, misconfiguration and so on. One helpful way of doing that is to actually be able to see the traffic flows. So is there some way of capturing and visualizing the traffic flows that are happening so you can see that traffic is being allowed? Are you sure you actually wanted to do that? Or you can see certain like, hey, this particular VM is attempting to violate one of the policies that you've said. Maybe you should take a look at that because maybe it's been owned by something.
Yep, absolutely. So there's a couple different ways, and one of them will enumerate in a couple slides. So Justin, you're the master of reading my mind and kind of seeing where things progress in the deck. And I promise, Justin didn't get an early copy of the deck, so he's not a paid for sponsor or anything to complete the conversation.
Is one of my less useful superpowers.
It's a good one. Okay, so just quick screenshot of what a distributed firewall policy can look like. And again, taking advantage of the tags where we've got web and app and database that are in turn going to be applied to virtual machines to then enforce the policy, right? So again, I don't have to care about the IP address of those virtual machines as long as they have the right tag. My policy definition is app can talk to database on Microsoft SQL, and then it's allowed. And we have also taken the approach of bringing some of the firewall UI enhancements from on-premises NSX and having automatic categorizations. And you can see a little bit in here, right, where we've got emergency as a category and an application where you can inject new firewall policy based on changing situations in your environment. So, there's, in this case, hey, there's a day zero hack that's called new hack, not very creatively named, that leverages the ultra secure telnet protocol, right? So stupid example, but I think it illustrates the point that my source is any destination to my web servers, which are typically exposed to the outside world. Anything on telnet is going to be dropped. So I have the ability to be able to insert that firewall policy because it is top-down firewalling. So we have guidance for customers on how they can take advantage of these categories to structure their firewall policy for emergency, infrastructure, applications, things of that nature to help simplify this and be successful. And that's part of this component of it where we start talking about taking advantage of the lessons learned from the last 5 or 6 years of on-prem microsegmentation to be able to bring that same discipline to VMware Cloud and AWS, right? Just because it's a different service doesn't necessarily mean that I change the way I think about it radically. I'm still able to use the same tools. I use VMware Cloud, VMware vRealize Network Insight Cloud, VRNI in the cloud, right? To monitor traffic inside the cloud. I can use it on premises to collect data about my applications before I move them. I can use vRealize Log Insight, both on-prem and cloud flavors. So the same kind of mindset and principles that we have for doing this on premises can be applied to the cloud, so I can simplify that journey to microsegmentation. The same principles apply.
How does it work about the licensing? I mean, all these features are great, but do you have to pay for them with a different subscription, or are they included because they are, you're talking about them as necessary anyway?
So definitely not necessary, right? But they simplify the capability for customers. Depending on the customer in your contract, it's going to dictate how much they cost, right? So some of them are licensed, some of them are included. It's going to be variable based on the customers. So you can do it the hard way too, right? You can do it without these tools, but I think that most customers have been successful by taking advantage of these tools, whether they're on-prem or in the cloud or both, to provide that kind of mapping and flow level insight for themselves. So last but not least, operations inside the software-defined data center. This is one of the things that I think, from my perspective, having been an on-prem guy for the last, I don't know, I got gray hair, so a long time. Being able to look at it from a service level perspective and being able to have a lot of these capabilities being online and self-helpish type of an approach, right? So literally, when I look at my cloud portal for VMware Cloud and AWS, I can click on a support button, and this window pops up, and I can do a context-sensitive search that will take me to how do I develop a distributed firewall policy, right? Or how do I define my rules? I've got links to the official docs. If I'm just looking for generic docs, I have online chat support who can help me immediately with some of my questions and capabilities that I might have. And then also having a cloud status page, so I can go, if I'm having a problem, hey, this screen's not coming up properly. I wonder if there's an ongoing issue, right? And I can go to this cloud services status page, and it will tell me if there's an issue. Additionally, we mentioned in Orion's session about the notification gateway. I've signed up for it, and I get notification whenever there's an emerging issue or anything else inside of the environment. And it's I don't know. I like to think I'm not easily impressed, but I'm impressed by being able to have this quick, proactive notification that, hey, there's something going on in the environment. Here's what's affected, and when the next update will be. So So for me, we've got that's all done through our site recovery engineering team, right? So our SRE team, who sits there and takes care of the environment, takes care of upgrades and everything else, and it's nice from an on-prem guy's perspective.
So quick question here, just again for confirmation. That notification, is it for your service, region, entire service? How does that work?
You can customize it, right? So I've signed up for everything just because I think it's interesting. But you might not care that, hey, there's a problem in Singapore if your services are in the UK, right? So don't sign up for those regions.
It's customizable then.
Yes.
Right. Thanks.
My pleasure. So we talked about vRealize Network Insight Cloud. Certainly part of that would be by taking advantage of IPFix that can be enabled on each of the individual switches or segments really inside of the environment. So here's an example where we've got a centralized collector that we're doing IPFix collection on. I've increased it to 100% packet sample, so it's in essence full IPFix. But you can also scale it down if you want to go from a sampled approach. So it comes down to the granularity and fidelity of what you want to see in your IPFix environment. Maybe I've got 100% day one, and then I back that off as I get more comfortable with my environment and I develop my firewall policy and whatever. And then last but not least, port mirroring. So to answer the question earlier with regards to how do I see what's happening in the environment, I can use Wireshark or whatever I need to use for my port mirroring functionality. And this will be, in essence, a packet level decode, right? The packet capture of what's happening from a VM to wherever. And I can send it to my collectors, either on-prem or in the cloud as well, right? So I've got options there. And additionally, some of the capabilities that are inherent to NSXT on-prem to help with near real-time visibility of the firewall policy are also coming to VMC. So this is kind of the step one. We're getting more on the roadmap. So stay tuned. All right, so in summary, I think we kind of talked about a lot of these things, right? So certainly the different VPN and connectivity options, whether it's VPN, DX, TGW. We touched on VMware Transit Gateway, although not as much detail as we would have liked to, but stay tuned. We'll get to talk about that a lot more. And then certainly, obviously, NSX being inherent to the entire solution. So you're not going to have a VMware Cloud on AWS solution that doesn't have NSX as part of it. And then last but not least, a list of resources that I think are helpful and useful for our customers. Obviously, do with it as you will.